Hello everyone. In this video we're going to be looking at an infinite fraction. An infinite expression in the form of a fraction. We have something like 2 plus, and then in the denominator we have a 2, and numerator is 2 plus, and then 2, and then 2 plus 2, so on and so forth. So instead of going downward, this is just going upward. So remember, if we have an expression like this, it's kind of easier to define or talk about, because we can call this 2 plus 2 divided by 2 plus 2 divided by so on and so forth. But this one is kind of going. This one is going backwards. So how do we do that? Similar approach. First of all, obviously, there's a rigorous issue here with the limit. Does this converge? And I can tell you that it does converge. How do you prove it? That's a good question, something to think about. I'm just going to go ahead and evaluate it non-rigorously, assuming that this expression converges. So, if our expression, the whole thing, is equal to a value, a finite value that it converges to, so let's call that x, and then we're going to get the following. We have a 2 plus, and then we have a 2 at the bottom, and everything is on top, right? So this expression actually contains itself, and how? Right here. If you look at this, it's the same thing as the original x, isn't it? If you look at it very carefully. If you want to write it out, that's fine, but I'm sure you can clearly see that this is also the same thing as x, if an x value exists, of course, right? So where do we go from here? Very easy. All you have to do is write an equation. The whole thing, like that, something that goes to infinity, right? I mean, there are infinitely many terms going up, but it's the same thing as the original. So this expression contains itself infinitely many times, by the way. For example, this is also x. So if you want, you can make a more complicated equation and you'll get the same thing, right? You can definitely try that if you want. If you did, it would look like this. You're going to have a 2 here, you're going to have a 2 here, and then this part will be x. Just more work. Makes sense? And of course, this is equal to x. All right, great. So let's go ahead and evaluate it. So the whole thing is x divided by 2 equals x again. Nice. This is a linear equation with variables on both sides. So what I need to do, get the variables on the same side. So when you have equations for algebra people, or for people who are new to algebra, when you have an equation like ax plus b equals cx plus d, if you have variables on both sides and you're trying to solve for x, you want to bring them to the same side so you can isolate x. Make sense? A very important algebraic principle. So that's what I'm going to do. I'm going to subtract x over 2 from both sides. Simple. And then we're going to get the answer. X minus x over 2, half of x, subtracted from x, is going to leave us with half of x, right? 2 halves make a 1, maybe, right? Most cases. So from here we get x over 2 equals 2, which implies x equals 4. All right? So that seems to be the answer. And can we check our work? Okay, how do you check your work? Interesting. But you can. And by the way, I just wanted to say something different for solving equations like this. I know this one is fairly simple. You can do it mentally. I'm pretty sure some people will say, hey, I did this in 10 seconds, 5 seconds. I don't know what the world record is. But anyways, you can also think about it this way. Half of x is being added to something else, and you're getting x at the end. So what could that be, right? And it's supposed to be half of x, because half of x plus half of x is just 1x. Make sense? You can also look at it that way. And when it comes to checking our work, let's see. Let me rewrite the expression here so I don't have to go up. So we have something like this. That's something that goes real weird. It's going upward. And we found that this is equal to 4. So if this is equal to 4, it's kind of hard to check. Well, it's not too hard, actually. Oh, so you can do two things. Okay, no. Let me think about this. So you can, this is the same thing as x, right? So you replace this with 4. 2 plus 4 divided by 2 is 4. Okay, great. So that checks in that sense. You can also do the following. You can assume that this is equal to 4, right? So what does that give you? It gives you, if this is 2, then this needs to be 2. And that means this is 2, so this needs to be 4, which is the same thing as the original. So assuming that the whole thing is 4 gives us the same result. It's consistent, so on and so forth. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Maybe I'll see you in another video. Until then, be safe, take care, and bye-bye.